Just know the stuff.
Hello and welcome back to Calculus 2. We have exam 1 review. So in your infinite wisdom, you voted to have an exam in 2 days. So let's take a look at the topics and types of problems and things that you should expect. First off, the exam 1 is worth the least amount of percent for the class. That's done intentionally for a few different reasons. One of which is that some of you never took the class with me, so you don't know what the format and the requirements on the exams are and so on. So if you don't score too well, it doesn't really count too much against you for the first one, right? And then you learn. It's like a trial thing, right? The other reason why, right, it's obviously also the least amount of material covered so far and so on. So there are a few reasons why this exam is weighted the least amount of percent. And then as you go on, exam 2, 3, final, the percent and the stakes increase. But by that time, you are already familiar with the whole procedure and everything, so everything works well. Now, generally on exam, I have 10 problems, and you have hour and 20 to solve that. Now, you could work through the break, because there will be a lecture right after the exam. We have to keep pushing, because each of classes that we have now is actually a double class. So we're not going to have a 3-hour exam on Thursday. We are going to have hour and a half at most, with distributing and collecting and all of that stuff, and a break. And then we are going to continue exploration of chapter 7 right after the exam. So exam, as I said, it's on chapter 6. We are looking at 6.2 to 6.10. We're looking at 10 questions. And all of the topics that were covered in the class are the topics that should be there on the exam. Now, to practice and prepare, you have the My MATLAB stuff, you have the homework, you have the quizzes, you have study plan, and then you have that sample exam in My MATLAB that you can all access, and then you have also the notes that will be posted by the end of the day. So, and the videos, obviously, of all the lectures, you can go back. I encourage you to form those study groups and obviously use the TA, right? Utilize TA to cover if you need any. So what are we talking about? We're talking about area between two curves. We have disk and washer method. We have shell method. Then we have, what else we have? We have length of the curve. We have surface area of revolution. We have physics. We have the exponential and logarithmic word problems. And then finally we have hyperbolic functions, and that's it. Now, if you did your lab 1, you've seen the problem which stated that you should rotate around x, rotate around y, the same function, different function, getting the same shape, which way you need to modify a problem so it works out the same way. The lab is very useful exploration and learning tool, because it gets you to connect these concepts together. So now when you are looking at this exponential and logarithmic word problems and stuff, you have your word problems and you have your exponential models that will, so we're talking about population, we're talking about the decay, and then taking the derivatives or limits or integrals of those things. And then we have, actually no, let's go in order. So area between two curves, you have two functions with the area trapped in between. You might have to set those equal to find limits of integration, or the limits of integration might be given depending on the problem. This quasar method and shell method, that's what I talked about already, is going to be rotate on X, rotate on Y, can be used the other method, and so on. So some of that stuff, yes?
So I'm assuming there's going to be a question when you don't give us a graph, instead you just give us the equation. So is it better if we know what the graph looks like in our minds, or to study what?
Yeah, I mean, graphing is the part from pre-calculus, so that propagates through the course. So sure, the more you know, you better off you are for everything. So I mean, you have to graph for area between two curves because you need to know which one is on top, right? Which one is on the bottom. That's given. The other part is you know, when you do the dy integral, one is to the right, one is to the left, right? Which one is the one to the right? Because it's right minus left. Length of curve, that's the one where you don't need to have the shape, right? Because length of curve is just a formula you plug in and you, but this length of curve had that interesting integral with that trick where you expand, add the half, and then compress, right? So that's the, right, that's that. And then the surface area of revolution had that extra function in the length integral. So now that problem turns either into U sub or another one of those evil compress, expand, compress, and so on.
You love those, huh?
Well, technically, those are the only ones you have, because we can't have many variety right now because the curriculum is backwards. See, when you're learning derivatives, you learn chapter number 3, which are all different ways of taking derivatives, and then you learn 4, application of integration. Then you learn chapter 5, which is theory of integrals, and then you go into application, but techniques of integration of chapter 7. So it's backwards. It should be 5, and then 7, and then 6, right? I don't know why is it backwards, but it's backwards. So your first exam, guys, in terms of all exams, you can have 4 exams, right? You have 3 exams plus a final. That's 4 exams. Your first exam is the only one that has the cheapest calculations, because the only integration that you can encounter is the U sub. That's it, right? Now think about exam 2 after chapter 7. Basic integration, U sub, and then what you have? Integration by parts, partial fraction decomposition, trigonometric integral, trig substitution, right? It becomes now the difference, like when you were going in Calc 1 and thinking, oh, is this a product rule, is it a quotient rule, is it a chain rule, is it an implicit differentiation, is it a logarithmic differentiation, right? You had all of those flavors of differentiation, and most of the time it's chain rule, but yeah, it could be implicit, could be all of this other stuff, right? And you had to think which is the appropriate. And your entire chapter 4 was, again, okay, what is the appropriate derivative now that we are applying, right? So sometimes you use the wrong one, you're supposed to use product rule, but use chain and so on. So in that respect, your first exam in Calc 2, wow, every integral is either basic or U sub. If it's not basic, it's U sub. If it's neither of the two, well, you're doing something terribly wrong, right? Because you don't know any other techniques. So that's the part of the you know, calculations and having these having this exam 1 having only one integration technique. Exam 2 is going to obviously change that. So exam 2 will have a lot of variety, and then
you making it, you don't know.
Then we have a surface area of revolution, right? We said that. And then now for physics we focus on the work, and then the force with the work or the spring, and we focus on the tank, right, when you're pumping water. So taking about 3 different problems there, right, for physics. Maybe I can write those 3. So one of them is calculating the mass as the integral of density, right? And then we have work, which is spring. And then finally we have pump water or whatever, a liquid. How about liquid? So pump the liquid up to, so that's 3 formulas. Exponential logarithmic problems, well, it's the exponential problems, obviously. It's called the exponential growth or decay. And you only have a single formula to worry about. The single formula you worry about is y equals a e to the k t. And then you replace those y and a with p's if you're talking about population, with m's if you're talking about mass decay. So it's the same formula over and over and over again. It's just you use different letters representing what concept you're going to use it for. So it's the same formula recycled. Hyperbolic functions, again, it's going to be some derivatives, some integration, right? There only can be U sub and chain rule. And then you also have that proof that I said that one of those properties you will have to substitute ease from definition of sine and cosine hyperbolic, and then work the algebra. That's not a calculus question, but since the whole thing is in Calculus 2, you might as well have one of those proofs. So these are the ideas for the exam. As I said, there will be 10 questions, and if the exam takes longer or whatever, has a lot of these problems that might be heavy on computing or something, I might have a replacement problem. Sometimes you can't remember a formula, you can't remember a concept or something, so you can replace that problem with whatever the 11th replacement problem is. Now you have to state clearly which problem you're replacing, otherwise it doesn't count. It's not going to be, replace whatever is wrong. That doesn't work. And also what doesn't work is replace 3 or 7. And then what else doesn't work is use this problem as extra credit and stuff like that. So there's no extra credit.
The quiz. The quizzes.
Their preparation. The extra credit is exam or after the exam. The quizzes are happening before exam, and that's the exam prep. So that's
fancy technical.
So yeah, there is no extra credit of any kind in my class at any level. There is a replacement problem, and there is the exam prep. That's all there is.
Pretty good. See you mañana.
Do you have any questions, concerns about the exam?
Post this now. Hold on. Go ahead.
Yes.
What do the quizzes do for your exam again?
Every night. Every midnight.
Yeah, I know you do that. What do they add to your exam?
One point each.
Yeah.
Wait, so I thought you got 100
But you do it so many times that the answer is like so obvious.
So the last one, you guys have the same answer.
Anything else? Yes.
For one of the quizzes on the archives problem, like you couldn't integrate it yet because you don't know whatever. Yeah.
Do you have the problem? It would be really interesting to actually do it right now.
I think I do.
Was
it quiz 3?
So I might have it.
If you have it, that will be perfect. By the way, the quizzes between you guys might not be the same because the computer software generates different numbers, different functions. So you share the common problem statement, but the numbers and functions might be different from person to person. So now we're going to have a problem, and I'm excited.
What curve passes through the point? Oh wait, no, not this one. I'll put this
Hi, still. Did that annoy you?
No.
Oh, okay, good.
Which curve has the greater length on the interval -2 to 2? Y equals 1 minus x squared, or y equals cosine pi x over 2.
That's it. Good. All we need to do is to compute this, and that's it. Right? So let's take which line has longer length, right? So what I have here is so let's call this F and call this one G. So now I need my F prime, which is negative 2x, and the G prime, which is negative pi over 2 sine pi x over 2 when I take the derivative. So the length of the curve for the first one, from negative 2 to 2, I am integrating the square root of 1 plus 4x squared, because I have to square the derivative. And then have the dx there. And do what?
Can you say that 1 plus 4x squared is like parentheses 1 plus 2x all the squares?
Nope. Doesn't work that way. So this is the length 1, and the length 2 is negative 2 to 2, the square root of 1 plus, and now I have pi squared over 4 sine squared over, that's a pi x squared, and then dx. Perfect. All right, what now?
Wait, wouldn't it be 1 minus pi squared over 4? Because it's a negative.
When you square the negative, it goes away.
Oh.
Right? That's the part. And 6 through 6. All right. So what should we do? I have to remember to open your homework. Anyone? How do we integrate?
Do you have like old exam files you can share with us?
I said there is a exam in my MATLAB.
But it's not like formatted like that.
Doesn't matter formatting.
Whatever. So why do they keep teaching it differently every year? Like in lower level guys, like in the high school stuff.
When you show up. So any ideas? What are we supposed to do here?
Intricate.
Intricate? You sub? I don't have X.
You just calculate.
Put 1 plus 4 squared, and then use ax, and then you get u to the 1/2, and then integrate u to the 1/2, and put it in.
Huh. Okay. So for the first integral, let's go blue. U equals 1 plus 4x squared. Du is equal to 8x dx, from where dx is equal to du over 8x. Does that help? Because from here we say that that 4x squared is equal to u minus 1, and then x squared is u minus 1 over 4, and then just x is the square root of this, the plus and minus, but we use the plus one. So would that help? The integral of let me see what we get. We get the square root of u times the du over 8 times the square root of u minus 1 over 4. That doesn't help either. Right? So this is what the trig sub is for from chapter 7. Solve integrals like this.
So we didn't learn this, alright?
I'm trying to wonder. What happened?
Refund the points.
Refund the points.
You couldn't Google the answer.
So, yeah. So what is the right? That it's actually a trig sub integral, and that's going to be 7.4. The one on top. 7.4. Unless, wait, can we do this by completing the? No, we can't do completing the square because no, never mind.
I already asked that. So, yeah.
No, if this was x, right? Because I need to make constant is the one that I can fix. So okay, so that's the rip the first integral, right? That's gone. How about the second one? Did you integrate the second one?
No.
Why not?
You need break.
I need what?
Break integral.
No, this was sine squared. So what do we have? Let's check what the algebra tells us for the second one. So it's 1 plus pi squared over 4, and the sine is written as 1 minus cosine pi x over 2, and this is all under the square root. Yeah, that one.
Told you.
Don't you do that a squared plus x squared? Yeah, you can trig sub squared.
Yeah, but that's in chapter 7.
I told you.
So we don't even need to worry about this type of problem in this test.
Yeah.
So I don't care. We're done with the problem.
Now, did it say? Let me just one more time ask, because it's different situation. Is it a length of the curve or the surface area over there? Length of the curve. Okay. Yeah, surface area has a function in here, so that changes the calculation. No, for sure, not allegedly, for sure. So yeah, this the answers to these questions, guys, are coming up in chapter 7.
I can't wait.
I know. Let's see what else. Let's do something that we can do in chapter 6. Anyone?
I have one. I do.
Well, I mean, I couldn't figure. I mean, okay, so it was like define the surface area of a cone with a radius of 6 and a height of 7 around the y-axis.
6, height of 7.
Yeah, I mean, I give you the I can give you the integral. I just can like integrate it from
The height like this, rotated around y, and then just to find the area of it.
the surface area. Yeah.
Surface area of the cone.
I can
Okay.
give you the equation.
What's the equation?
It was 2 pi between 0 and 6 of x times -7 x. -7 over 6x. Sorry. Plus 7.
Like this?
Yeah. It may not have been a surface area one. It might have just been defined. Are you like using something? That was it was like a study plan question. Like that was the correct integral. I think.
X times -7 over 6, right?
Yeah, it might have been a shell. Probably shell like the question.
You distribute x.
I did. Yeah.
Okay, so we have 2 pi integral 0 to 6. We have -7 over 6x squared plus 7x dx. And now we integrate. So 2 pi. Now we have -7, that's going to be a 3, so -7 halves x cubed plus 7 halves x squared computed from 0 to 6.
I don't know if that was yeah, probably was. I probably didn't change the 6 to a 2.
This one?
Yeah.
Because
the first one. Yeah, sorry, that one.
Oh no, wait, that's not a 6. That should be 18.
I said that.
Okay, never mind. So yeah, no, we're good.
Should be 18. Sorry, should be 18.
Okay.
And then you plug in 6 and subtract.
And you plug in 6 and you subtract, well, zeros will kill it.
Yeah.
So 2 pi, and then you have -7 over 18. Now 18 is 3 times 6, and this is 6 times 6 times 6, so one of the 6's is gone. And then this 6 and this 3 gives you a 2 over there.
21.
And then, no, it gives you 2 over here. Come on, there we go. Gives you a 2 over there. So that's
84.
-84. So -84. And then plus on the top we have a 6. That's 1 cancels, so that's over here we have 7 over 2 times 6 times 6, and that's a 3. So 21 times this is 126. And that's now 42. So 84 pi.
I just probably messed up where I tried to take. I think I tried to take the 7 out and I put it in the wrong place.
Okay, so 84 pi. That should be it.
Pretty good.
Oh, thank you. Anything else?
See you mañana?
See you mañana.
Well, all right, hold on. How about this? Alright, so the disk x squared plus y squared is less than or equal to 9, is revolved around a line x minus 5 equals 0. Creates a torus, and then you gotta find the volume of that.
Yeah, that's a spicy one. I like that. That's so. What was the? Can you read one more time? So the disk.
Alright, the disk x squared plus y squared is less than or equal to 9, is revolved around the line x minus 5 equals 0 to generate a donut-like solid called the torus. Find the volume of torus.
All right. So what you have is you have a circle that has at the origin with the radius 3, and then you have the x-axis extended, and then at 5 you have the axis of rotation, which takes this circle and brings it to the other side over here, creating a torus, right, which is a donut-like shape. And what is the volume of that torus? So there are a few ways in which you can do this. I generally shift the functions so that I can work with this. So here's what I'm going to do. I'm going to take my integral, because this is rotation around line x equals to 5. And I need to shift everything 5 units to the left. When I shift everything 5 units to the left, my equation for the circle becomes x plus 5 squared, and then plus y squared equals to 9. So my center for the circle moved to -5 because I shifted everything to the left 5 units so that I can have my axis of rotation to be at the y-axis. So now I have my y-axis over here and rotation on the y-axis, and now the circle on this side goes on a circle on the other side, creating again the donut that we want to see. So now I have my axis of rotation where I want it. Now, if I look at the symmetry of this, I can actually work with the right-hand side or the left-hand side. It doesn't matter which one I pick. The key is to, when you solve for y, you will get 9 minus x plus 5 squared or minus 5 squared. You are going to get a square root and a plus and minus. You see, the trick is you can't work with the plus and minus there. So if you just take plus sign, positive sign, you are integrating half of the donut around. So you integrate half, and then at the end you will multiply by 2 to get the full volume. So now your function f of x, right, which is going to get rotated, your f of x is square root of 9 minus x plus 5 in parentheses squared. The next question is, what are we using? Are we using dx or dy for this calculation, right? And what are the limits for the integration? So you go and you say, all right, I have this shape, right? And I am integrating. I can't integrate this way, right? Because left and right sides are hitting the same function. But what I can integrate is dx. Now dx over here is parallel to the axis of rotation. So if these two are parallel, that spells shell method. So I have to use shell method. Great. So now I have my function, and I know how to set up the shell method. It's going to be dx setup. Now also, when I moved everything 5 units, I also moved my limits 5 units for integration. So I have the left-hand side to be -8 and the right-hand side to be -2. So I need to integrate -8 to -2. So the volume is going to be 2 times, because I need the upper and the right, and then we have 2 pi integral -8 to -2. Then I have my x, and then I have the square root of 9 minus x plus 5 squared dx. What an awesome problem.
How did you get your bounds again?
Like this.
Yep.
When you shift everything 5 units to the left, right? So you are going to have the difference as -2 and -8, right? You can work on the right-hand side. Maybe it would be even better if you
You take the original balance, -3 and 3, and just smooth that 5 over. So
yes, 5, yes, -8, -2, yeah.
Now you get it.
If you didn't move the bound over and instead kept it the same, then instead of just x times the square root of 9 minus x plus 5 squared, it would be x minus 5 times the square root of 9 minus x squared, right?
5 minus x, yeah. No, we are shifting left, right?
If you didn't
No, 5 minus x,
if you
yeah.
didn't shift with,
Yeah. First I shift because it's easier. And now you do some u sub witchcraft over here, and because you have x in front, you have x squared underneath, right? You should be able to deal with that.
Would you exit? Not exit. Would you use the entire thing underneath the radical or x plus? What would you use it?
What would I u sub it with?
Yeah, would you expand and
Yeah.
then collapse and then you sub that?
The thing is, when you FOIL the x plus 5 to do itself, you're going to get 10x in the middle. That's going to leave you with a du of like 2x plus 10, not like 10x. So how would you make it, like add the 10 to the outside to make it like du? Can you just add 10?
Okay, let's take a look. So 4 pi integral -8 -2 x, and then over here I have square root of 9 minus, that's going to be x squared minus 10x minus 25 dx. So 4 pi -8 -2 x square root of, and you have -x squared -10x and then -16 dx. So now if you do the u sub, that's going to be -x squared, so that's -2x minus 10. And if you, sorry, this is the -x squared minus 10x minus 16, and then du is -2x minus 10, all of that dx.
You just add plus number to the du and you set it back in.
I don't think it's this simple.
Right.
No, because you can factor out -2. Factor out -2, you get x plus 5 dx, and you don't have that plus 5. -2 you can fix. That's not an issue. I don't have x plus 5. So what should I do for that? So you sub this and then you sub again. So hold on, let's see. So now we do this substitution. I'm just going to leave this blood trail over here for the limits because we'll have to deal with that. So what I'm going to do now is I'm going to say that the dx, so from my calculation over here, dx is equal to du divided by -2 of x plus 5, right? So what do I get? I get x times the square root of u, and then du divided by -2 x plus 5. So the -2, that's gonna go outside, so I'll call that -2 over here. So I just have x plus 5 on the bottom. Can I can I use sub? Long division. These are some nice spicy problems. I like this. Why not? It's fun.
I asked because I didn't know the answer. Dude, what you have wrong?
Someone is bound to solve this.
So, yeah.
So let's see.
Take the time.
I'm not saying I don't.
All right. So all we need to figure out what to do with this over here. That's the only problem that we have. So if I do, okay, let me see. So what do I get if I do the long division? So that's x plus 5 divided into x. So we get 1. Multiply back, we get x plus 5. Then when you subtract this die, and then you get negative 5. So it becomes negative 5 over x plus 5. What?
This is way worse than what we had.
We don't know that yet. 1 minus 5 over x plus 5 root u du. Now hold on. Because this now over here is very close to, this over here is very close to using the, it's ln in a substitution.
It is or is close to? Math is close to, still wrong.
I don't like it. So let me see one more time if I missed anything. But that's technically. So we have x squared plus y squared less than 9. That's equal to 3. Right, this just tells you that the disk is full. This less than equal to. That just tells you it's a solid disk. You rotate that around, you create a donut. We shift everything to the left. When I shift everything to the left, the axis of rotation goes there. My x coordinate moves to at negative 5 squared. The y stays where it is, equals to 9. That's a radius. So that's going to be 9 minus this to give us y. Okay. And then this is, yep, this is it. And then all I need to do is to integrate. Oh no, that's good, it's good. For the moment I thought I forgot to square. That's for the washer and disk method you square. I thought that I forgot the square over here, which would kill the square root, and I was almost, but then I remembered, yeah. No, this is good. So 9 minus x squared minus 10x minus 25, that gives us 16 over there. This is a very spicy problem. So now we have du is x plus 5.
How come x plus 5 is on the bottom?
Because it's on the bottom.
Oh.
Right? The dx is du over whatever the leftover, right?
Yes.
So now that's x plus 5. Our substitution is not x plus 5. So I can't use sub over there.
Divide by 0 and call it a day.
Divide by 0 and call it a day. That's one way to deal with problems in life.
I mean, you don't plug it in, but then, like the original integral that you get, you plug it into an integral calculator online, like, spits out, I think, like a negative number or something.
Oh, hold on.
Like the sums upstairs and then I'm not sure.
Hold on. So let's use the other side of the equation. It's going to be from 2 to 8, and the function over there is y equals 9 minus x minus 5 squared the square root. So now this is the square root of 9 minus x squared plus 10x minus 25. So now this is 16 minus plus 10x minus x squared. So that would be our function. Does this help in any way?
It would just be x minus 5 in the end instead of x plus 5.
Yeah.
That's all it changed.
This is too spicy for my teeth, but
No, this is awesome. Because eventually we'll figure it out. And when we figure it out, then you win.
I will stay here all night, man. I'm ready.
Yeah.
I'm studying what's on the wall.
You don't know if this is going to be on the exam or not.
Yeah, thanks to you. North.
It's already on the lab.
North Ball.
No, it's not.
More of a symbol lab guy.
That's what he's doing right now.
No. I'm just trying to find, to see if there is. Yeah, where you find these nice integrals like this?
In the lab.
Oh, this is on the lab?
Yeah.
Can we take it off the lab?
This type of question is from the lab. That's why I was so confused.
I thought that this was one of the homework questions. The lab involves numerical integration. So not every
We
integral.
go over the lab.
Yeah.
No, it is on the lab.
But like,
You see, now we reach the problem because I'm solving a lab question which I'm not supposed to do because this is graded material. It's not impossible. If you plug it in, look, lab has a requirement of technology. Not every integral can be integrated by hand. A whole bunch of integrals are done strictly numerically.
Come on, bro. Numeric.
So when you plug this in a software, you're going to get a number. You see, that's the problem. So now I have to, yeah, this is,
You can't even go over this one.
so,
yeah,
so for, on the lab, you wouldn't expect us to show all the work for this.
not for the integrals that can be solved by hand.
How are we
only-
supposed to know it's supposed to be not be solved by hand? If we
But when you get stuck, because right now I am looking for a way to go around of not using advanced techniques or something like that, just to use the basic stuff, because the only thing that I'm limiting myself to right now is the U sub. That's the only thing you know. So if the U sub is not working, you might as well say can be integrated. You have to use the computer, right? For the homework, there is a difference between problem 25 and 25 with a T, like that, the blue T. The blue T means you have to use mathematical Wolfram Alpha or something to actually get the answer, because you cannot integrate. And you have a whole bunch of those problems in a textbook. I'm trying to find, there they are. So if you let's say look on problem page 443, problems 50, 52, 53, and 54, they all have a T in it because you can't integrate by hand. So on the lab, every lab is going to have questions that you can't do by hand. What we're focusing on the exam are the problems that you are able to integrate either using basic integration or use substitution. So that's why this is a really cool question to explore and learn and work on it.
Because I was working through it for like a few hours, and I just couldn't.
I know. All right, I guess this is done.